Hello all, I am Bishwaranjan Sandhu, and today we'll be discussing about XML data and XQuery in SQL Server. Um, Guys on GTM, can you hear me? Hello. Okay, let's start. Today our seminar topic is XML data and XQuery in SQL Server. As we know, XML
Hello.
is a very much widely used and widely popular data type. Normally not only limited to the SQL Server, but also limited to all the applications, different type of applications, not only .NET application, PHP application, but also it is used across all different types of domain and different type of applications. So today we mainly focus on how we can use this XML type of data into our SQL servers, and also how we can manipulate our data, relational data, all the tables, rows, columns by XML data types. So this is my introduction, and this is my name. Then my next slide is all about me, whatever I am doing from last 3 years, and what are the different technologies I have worked from the last 3 years, what are the different domain as well as different platform I have worked from the last 3 years. And below is the different type of certifications I have done from from starting from the joining of in the Mindfire solutions. So I have 3 certifications in my name. First one is web development, second one is for MVC, and third one is for HTML5. So then my next slide is about our agenda, what we will be going to discuss in this seminar actually. So my first point, we will be discussing about basic syntaxes and use of XML data types in our SQL servers. In this semi slides, we will be discussing about different comparisons among different relational data, and also the XML data models, why we choose XML data model other than the relational models, what are the circumstances we have to consider before choosing any relational data model or XML data models, and then we will set some conditions or set some parameters. We will outline some of the different some arguments you can say, so why we will use XML data types. Then we will in the same slide itself, we discuss about how we can use that XML data types, where SQL Server has introduced XML data types into SQL servers. Then in the same slide itself, we'll be discussing about how we can implement those XML data types in SQL servers in our table structures. Then in the last point of this seminar slides, we'll be discussing about some of the limitations of the XML dataset. Every data type has some pros and cons, and we will be highlight some of the major limitations of the XML data types which is lacking in SQL servers. So then my next slides will be about FOR XML clause. In this case, we will be that FOR XML clause basically responsible for retrieving the XML data from our relational data from our table structure, and we will show how we can use those FOR XML clause to extract our relational data and simply put in a XML schema. And in that slide also we'll be discussing about different types of modes like raw mode, auto mode, path mode, and those modes we will be using to construct our XML schema from our normal table structure data. Then my next slide is about raw mode. In that slide we'll be particularly focusing on raw mode of FOR XML clause, so that how we can we will be discussing more about how we can use that raw mode in the XML raw mode with our relational data, and how we will construct our XML with raw mode. Then the next slide is about auto mode. So this raw mode, those auto modes, these are basically their internal architecture is same, and everyone does what they do is simply they output the XML schema, but they are little bit different in their syntaxes. Then we will discuss about path mode, and how we can use this path mode of FOR XML clause to construct our XML schema. Then we will look a bit at OPENXMLs, and this is just opposite of all those above FOR XML. In the FOR XML, normally what we do is we simply extract XML schema from our relational data, but in OPENXML we just do the opposite. From an XML we will just extract the relational data and like records. Then we will little bit we will show some examples on how we can use XQuery on those XML data generated through raw mode or path mode, and then we will play with some of my examples. Then let's proceed to the next slide. Next slide is about first slide is basic syntaxes and use of XML data types. As we all know, as I said previously, XML data is widely accepted in every applications as well as in SQL Server. So why actually we will go for a XML data type rather than relational data model? All we know is relational data model. We are very much familiar from our college and schools, and it is very much simple. Like we can easily manipulate all those data, select star, insert into, update into, everything we can easily manipulate. Then why we will go for a XML data structure? So let me first we will do a comparison between relational or XML data model. So first, whenever we start say any applications for our project, what we will consider? We first consider what will be our data, how we want to store our data, what are the different data we will be keeping into mind, and how we will be using those data. So for this thing, so normally we first visualize our data thing, then we visualize whatever, how we will be store those data into our database tables. So first we consider a schema type of thing. Suppose I will be using some product website I will be designing. So first of all, what do you think? There will be some products, and those products will be involved into some of the categories thing. So first my schema will be designed. I will be some product table. In that product table, I will be putting my product name. Different product categories will be some different tables, so that I will be relating which product to which category. So everything will first determine into our mind. So first of all thing, we determine the schema of the tables, and everything first we set. So if we already set, we already know what will be the schema, what are the data we need to store, which is already structured, everything, then in that case obviously we should go for a relational data models. So in a single line, if I say if our data is structured and with a known schema, then obviously we will go for a relational model. But what if we don't know what will be the data? Suppose we are using a third-party interfaces, and those interfaces will be returning some of the data. So in that case, we are not sure what are the data they will be returning. In that case also, we are not sure what will be the size of that data. So in that case, we are not sure on what are the schema of the data, what are the layout of this data. So in that case, we will be using our XML data models. So in a single line, if our data is structured and very much simple, then we will be using relational data model. But rather, if we don't know the structure of the data, we don't know the schema of the data, then obviously we will be go for a XML data models. So, and there is another, so we will be just outlining some of the points in some of the points if which it is not satisfied, then we will be go for a XML model. So my first point will be, as I said, if the data is unstructured, we will be going for XML data type. The second is, if there is a possibility that data will be repetitive in that structure, whatever the data we will be getting. Suppose we are using a third-party interfaces and we are getting some data, and there is a possibility that data is being repetitive and some of the data is incomplete, unstructured, then in that case also we will be using XML data models. Then the second point is, if the data is conveniently hierarchical. I mean, suppose the data is scattered kind of thing, and it is not relational cutting. Suppose product categories, it is obvious that those are related kind of thing. We can easily imagine that that product is categorically into that categories. So in that case also we'll be using relational data model. But if we cannot categorize some of the data to any root or something kind of thing, then in that case we'll be using XML model. Then then there is another point where there is a possibility that the data is, frequently we need to modify some part of the data. Suppose we have a large big size data, and we want to change or we want to query some part of the data, not the whole data. So in that case also we can go for a XML data model. So if I outline all the 4 points again, so if our data is unstructured, then we will go for XML data model. If there is a possibility that data is recursive, then we will go for XML data model. If there is a need that we want to insert query some part of the data, then we will be going for XML data models. But if any of these 3 above conditions doesn't satisfy, then obviously we will go for a relational data model. I just want to confirm here that the XML data model has its own significance, and it will perform its role in a significant different way. So it doesn't mean that we always XML data model, it provides some of the features So that, but doesn't mean that we'll always go for a XML data model. So whatever the 3 points I have outlined, if those of the conditions satisfied, then only we should go for a XML model. But if any of those above I mentioned 3 conditions doesn't satisfy, obviously we will go for a relational data model. Then my second slide is about why SQL Server is introduced XML data type into our SQL Server. Then the suppose the first point where SQL Server is introduced XML data into SQL Server is the same thing. If there is a large amount of large size data, suppose we are interacting with some third-party applications, or simply we have a bunch of data and you want to use the data into you want to insert those data, update those data into your SQL Server data, then it will be whatever we'll be using. Varchar max, that is the default data type SQL Server is providing. So personally, I have used Varchar max, and it is very, very, very slow to operate those big amount of data into our databases. Suppose if you are using in a string Varchar max format and simply we are manipulating those data, then obviously we will be writing some functions to extract those data. We'll be passing some argument to extract those bunch of data. So we'll be using some scalar value functions. So in those scalar value functions, it will be very, very, very slow. But if we use XML data type, the SQL Server provides some of the keywords, some of the features, some of the modes, so that we can easily, it is very much fast and it is very much efficient. And moreover, we can use some transaction kind of thing also in the SQL XML data type, so that if anything goes wrong also, we can handle those errors kind of things in the XML data types. The second point is why SQL Server introduced XML data type into SQL Server is if our data, if in our application, suppose we work in a .NET application. So in the .NET applications, some of the parts suppose our data we needs to display in a XML format. Suppose we have some health record informations, and we want, suppose whenever a patient logs into his portal, patient portal, then he wants to download his health information as an XML data types. But suppose if we store our data in a Varchar max kind of thing, so obviously we have to write our code in such a way that it will be formatted into some XML format, and then it will be shown. But if there is any XML data type kind of thing in SQL Server, then simply we will put those data XML format directly into our SQL servers, and whenever we need, we just extract those data from that table, from that column, and simply throw that user that data. That's why Microsoft introduced XML data in the SQL Server. Then third point why also XML data type is needed is same goes for if there is third-party applications and it is returning XML data types. Then and we want to store those XML data into our tables by querying all those data information. So in that case, if we store those Varchar max kind of thing, and if you extract those data, then we have to do our extra work, extra scalar functions we have to write, and we have to insert those data into our tables. So if we have a XML data kind of thing, and if Microsoft provides some of the keyword syntax kind of thing, then we can easily query those large bunch of XML data, and we can easily manipulate those data in our SQL servers. So these are the reasons behind why Microsoft introduced XML data in SQL servers. Then third point is XML storage option. So how we can store XML data in SQL servers? As we can see, there is Microsoft already providing XML data type in SQL Server. So we can simply name a column as XML type. Data, whenever we design any table, any column name, simply we can put data type as XML and simply done. So we don't need to do anything else for storing the XML data types, and that is very much pretty enough simple. Then what are the limitations XML data types? Every data type has some limitations in SQL servers. So XML data also has some of the important limitations, like we cannot store data exceeding 2 GB in a XML data type columns. Suppose we are getting some data from third party or something, and we don't know the size of the data. So XML data by default supports maximum size up to 2 GB. If your data is exceeding 2 GB, then it will not able to store the data into your column. The second limitations of XML data type is we cannot convert those XML data into text data type, or and text data types. Sometimes we need our XML data types to convert into some string kind of thing. So we cannot convert it into text type, though we can convert it to varchar max kind of thing. XML data we can convert it to varchar max, varchar and varchar. We cannot convert that to text or end text. So in certain times we can't say that we don't need to convert to text, right? So in certain point of time we may need to text to convert. So this is a limitation for the XML data type. Then third point is in the XML, as in the XML data type we specify a column there, then in the SQL Server it will be putting those in a hierarchical structure. So the SQL Server needs to point out what is the root and which node is related to which node. Those kind of things will be putting in a hierarchical structure. So in a normally group by clause is not applicable to those XML data type. Suppose if we have a XML column, normally whenever we have varchar int, we can use group by column easily, right? So if we use some XML data types into our column, then it is very much difficult. We cannot use that group by column in an XML data type columns. So these are the basic limitations for an XML data types, which should not be happen in SQL Server. So these things need to be taken care, and obviously Microsoft will some days may take care of that thing. So this slide is something we discussed about basic syntaxes and use of XML data types. We just done a comparison between relational data model and XML data model, when to use relational data models and when to use XML data models. Then we discuss about some of the why Microsoft introduced XML data types in SQL Server. Then we discuss some of the storage options, like how we can use those XML data into our SQL Server. Then we discuss some of the limitations. So any doubts in here? Any questions, comments? Okay, then next, let's proceed to the next slide. Okay, so our next slide is about the FOR XML clause. So as I have mentioned earlier, FOR XML clause is, this clause is used to extract relational data from our table structure and import, and it will be outlined as a XML data. Suppose we have different types of tables like customer, category, all those different types of tables, and we have records in those tables, and we want to get some XML data from those records. So in that case, that FOR XML clause is used. So FOR XML clause is providing some of the important arguments we extract our XML data from our relational data. So first argument is about raw element name. So raw element, what it is a type of mode for XML clause, and we will be discussing more on individual slides of the raw mode. It will simply extract the records from the database table as a row. For the public identifier will be row, and whatever the data it will be returning row node, and inside that row node the data will be there. Then go for the auto mode, and in this case we cannot handle the XML schema properly through this auto arguments mode. Basically simply we have to extract all those data, and if we extract those constructing XML data through auto mode, then it will automatically, as the term itself signifies auto mode, it will automatically construct the XML schema for you. So we cannot handle what will be the output of your XML schema. It will just simply, according to your records, it will just outline those XML schema it will generate. Then the explicit mode, it is the very much complex type of modes, and it is very much in the raw and auto mode we cannot what we can say, we cannot manage, we cannot handle the schema, and we cannot control how will be our XML outcome. But in explicit mode we can explicitly specify our some of the syntax and everything, and we can explicitly manage what to be the outcome of the XML. Then our fourth mode is about path mode, and in this it is the most easy way to handle the XML schema, and it is the most efficient way of generating XML schema for the relational data. XML data and those things will be supposed whenever you are working in a XML data applications, we need to define the schema for the XML data, right? So if we all familiar with XSD kind of thing, suppose whenever anything, suppose whenever there is some data, there must be some schema for that data. Like whenever we design a table, we have schema for that table, like the design pattern for that table. So whenever there is some XML data, So it must have some schema type of thing. Suppose this, suppose I have customer is the root node, then customer name is his child node. So there must be some schema which indicates that customer is the root node, customer net should be lies inside that root node. This is the schema actually. The file which describes the different hierarchy will be the schema for that XML. So through XML data or XML schema, we can easily generate the schema for a XML type, XML data type. Elements will be, we can play with the XML data generated with the elements arguments. Then there is another mode for XML class providing is binary base 64. Suppose we are storing image into our databases and we want to generate XML schema from that image data type. So in that case, if we don't use binary base 64, then it is very much difficult to extract binary type of binary type. So we have to use binary base 64. Microsoft is providing a SQL Server for manipulating the image type of data. And type is, if you specify type, then it is sure that it will be generate a XML type. Right? So then is the root. Root means if suppose we want to put every our constructed XML nodes into a root kind of thing. So in that case, root argument will be used. So individually we discuss more about some sort of arguments there. So let's proceed to the next slide. Working with the raw mode for XML data. As I have told earlier, the raw mode actually what it does is it will simply extract the records as a row wise, and the generic identifier is the row. So suppose I have a customer data and I have inserted customer name and customer type into my database. Then whenever I use this raw mode, then simply it will return row customer. In a generic identifier is row. So let's see some sort of examples how we can use raw mode for XML data type. These queries I have already prepared to minimize our time. It is not visible properly, right? Let me help you by oh yeah, I can do that. Is it visible? Same thing, right? Little bit. Okay, let me help you by showing the schema for those. Is it visible, right? This is my customer table, and in my customer table, I have, if I run a normal query, you can see. This is my customer ID, my customer name, and my customer type. This is pretty much simple enough. There is a customer table, and I have two records only. One record ID 1 with different customer name and customer type, then second record with a name and its customer type. So suppose I want to construct a XML schema from these records. So if I run this query, you can see if I run and execute this query, let me choose the database. This is my database, and suppose I choose this one, and if I click the execute, so it has generated the XML data for me. So suppose let's click, let's see. As I told, row mode will by default implement row generic identifier. Node name will be row, and it will put the attribute as product model ID and name. I mean the normal, the whatever my table name will be and whatever my column name will be, it will simply put all those columns name as an attribute type. But as I told previously, there is a attributes. The raw mode is providing elements, and if we specify the elements there, then it will generate all those in a node kind of thing. Like suppose mark the query syntax as select product model name. This is my two column name. From this table name for XML raw. Raw is the mode here, and this is the for XML. We are using for XML and the raw mode. So it is generating this structure. By default, those node name will be row, and all those column names will be like attributes. But suppose I want to column as a node kind of thing. So simply I can write select product model ID name from product model for XML raw comma elements. This extra line, if we add their elements, then it will automatically generates in a node kind of thing. Let's see row. Previously it was, if we don't specify elements there, it will be attribute. But if we specify elements, then it will generate elements for you, like those columns product model ID name. This goes the element. So suppose we have some in our data. Suppose we have some nullable data, in this product model, if I query this table, as you can see, I have different types of I have more columns there: color, thumbnail, photo, instructions, and in colors I have null elements. So if we do not specify, if we want to also include, suppose element is there and I am not this simply I am extracting this one and I am running. Suppose I am running like this, and the colors column may have some nullable data, right? So if I execute it, then we can see if for this record color is null, that's why it will not create that color node. But for the second record, there is a value for that color, so it is automatically getting. But supposed to keep our consistence, our all those structures, we need to include those things. So simply by writing this one, we can easily there is a keyword that access INL, this one. By if we specify this one access INIL, so it will also outline all those columns with null. As you can see, if we click this one, see color is empty. So now we don't have to explicitly handle those null kind of thing. I mean, suppose this we can easily use that one as it is already, if those null columns also already outlined, right? So then my next example is, like suppose I want to create that XML schema from that XML model, and I want to know how the data will be stored. So if I put the XML schema keyword there in this, then it will be generating the schema for that XML. Like see, these are the two XML data it is generated: row, product model ID, and these are the two attributes. So for these two XML types, this is the schema. See, this product control ID will be attribute for this element, row element, and this product name will be a attribute also for this element. So basically this will outline a schema for this XML data. Okay. So then my next example will be, suppose I want to use some binary image. Suppose in my product model I have also product image. So if I want to create XML data for those binary data also, see, whenever we use any type of image, those data are binary. So in that case, suppose we also outline those binary data into our XML servers, then we have to use this binary base 64. Select product ID model, the binary data column from product model for XML raw, comma binary base 64. So if I write this one and I execute, then it will outline all the binary data into my XML. As you can see, this is my binary data which was stored in my binary column, image column. And then suppose I want to include all those things into a single root node. Then I can specify select product ID name from product model for XML raw comma root name, whatever the root name you want to include all those XML data. So by executing this one, sorry, see my those two records previously, whenever we do not specify any root element, those will be single row. So if we want to include some of the root elements for those elements, then we simply write select whatever the columns we want to select, product model ID name for XML raw comma root, whatever the root name we want to give. So this goes for the raw mode. Suppose we there is another mode there, auto mode. Then in this auto mode, as I have told you, we cannot control the output of the XML schema in the auto mode basically. So simply it will generate whatever the XML schema as per your column names kind of thing. So let's see how let's directly go to the examples, how the outcome of those relational data with auto mode. Okay. Suppose I have this customer model. Let me help you as it is not clearly visible to screen. Suppose I have this customer name, customer table, and I have this column. Customer table has customer ID, customer name, and customer type. Okay, this is the schema for the customer, and the sales order is, I have a sales order table. In this table, I have that customer ID reference from that customer table, and I have order ID. I suppose I have provided a order, then I stored that order ID there and the status of that order, whether that order is delivered or successfully dispatched, something kind of thing. I am keeping those status in this column, you can say. So suppose I want to retype customer ID, customer order, customer sales order status from the customer ID. Suppose see this query. Is it bit visible now? See, suppose I am retrieving the customer ID, customer name from the customer table. Then I am retrieving customer ID from sales order table. Then I am retrieving this ID and status from the sales order table. As you can know, customer table I have provided a alias name cost there, and sales order header table I have provided a order header there, and I am doing the simply normal joining kind of thing. And then I am doing an order by. Why that order by customer ID used it? Suppose I want to outline something, customer ID 1, I have this sort of order, customer ID 2, I have this sort of order. But suppose if I do not specify that order ID, then whatever according to the order table, whatever number the records will be there, it will simply outline all those records, it will create. But suppose if I do the order by customer ID, then it will order my XML schema as customer with customer name. So customer ID, this number of orders, customer ID, this number of orders. So let's execute and we see how the data is being generated. See, I have already provided a root name cost, that's why it is outlining everything in a cost for these two nodes. I am outlining with customer ID. So for this is the customer ID, customer name, customer type. These three are coming from directly from the customer tables. And this table, see, for that customer one, it has two order. So it will simply put this customer ID for these two records. As if I show you the data in this other table, as you can see customer ID 1 has two records, two sales order records. Customer ID 2 has one record. So for customer ID 1, there are two order header. So this outcome is coming like this because of that order by customer ID. If I remove that customer ID, then it will be simply it will output as like this whatever the records present in the tables. As it is already auto mode, so we cannot compose anything. It will automatically generate those schema as for the records present in the tables. So same goes for the binary data. This is basically same with the raw mode and the auto mode. Actually, simply we are changing the keyword auto or raw mode. So in the raw mode, whatever you alias you give, whatever you give, it will set to those things. We cannot manipulate our, suppose you want to give some rename kind of thing to some of the nodes. So it is very much difficult to manage through auto mode. It will automatically set whatever provide in your query, whatever alias you give in that query. So this is the auto mode. So let's go for another better mode so that we can manage everything there and we can easily query that XML results table to generate XML schema. So my next slides will about the path mode. This is also a for clause where we can use those path mode. For that thing, I'll be using some different sort of tables. Suppose imagine the situations where I have a some books kind of things, and I am storing my book, basic book information in my book info tables like book name, book ID, all those things. Let me select all those so that it is clear. It is bit clear, right? So suppose I have a book table where I am storing public book of the name, the description of that book, and some sort of publisher name, publication name for that book. I am storing in the book info table. Then suppose that book may have different genre. Suppose any book is specific to some kinds of genre, right? Suppose some books are adventurous, some books are mythological kind of thing. So those information for that book I am storing in the book genre informations. Then I have a, suppose that book has different types of format. Suppose my book has a PDF format and ebook format or some different type of format. Suppose Kindle, Amazon, so Kindle, those type of formats. So for particular book, suppose I have different type of formats, so I will be keeping those information in the book format tables. And suppose a book may have possible that 2 to 3 authors combinedly written a book. So I will be keeping all those information in the book author table. So if I show you the schema for that tables, then directly I am selecting this one. This is my suppose different types of books I have in my book info table. As you can see, I have 3 books which were with publisher name, description name, and the book's name. Okay. So suppose for this book ID I have different format. Suppose for book ID 1 I have 2 format, PDF and hard copy format. Okay. Then suppose genre, for that particular book ID 1 I have different type of genre, like as you can see, fiction adventure. I mean that suppose book 1 is of type fiction adventure, so those type of information I am storing in the book genre informations. Then book author information. Suppose the first book is written by 2 to 3 authors or something kind of thing. So suppose that book ID is written by Robin Sharma. So this book is first book, book ID 1. As you can see, there are 2 records for book ID 1. So I have 2 authors for that book ID 1. So Robin Sharma and Amish Tripathi. Those 2 are the author for that first book ID. So all those information I am storing in this book author table. So suppose I want to create some XML kind of thing, like book ID 1. It has all book ID 1. It has who are the authors I'll be outlining. What are the genre for that book. What are the format for that book I'll be outlining, and I will be creating some XML kind of thing. So how we can implement that thing using for path mode. So as for this is the syntax. This is basically all the syntaxes are same. Simply we have to just change the path, raw or auto. So in that path we can handle it more easily. Like suppose I am selecting book ID and I want to this book ID as an attribute to that generated XML, right? So I'll be using as a @ if I specify as means this will be the node name. Whatever the XML will be generated, this will be the node name. So if I specify @ book ID, then it signifies that it will be attribute to that node. So as you can see, this is the final book info, and I will be outlining all those inside a book info time. So here XML path content. So path inside that one I have specified content, means my generated node will be named content. So in that way I can manage to rename that thing with my own whatever name I need to give that node. So this will be my content. So whatever the generated will be, whatever XML for a book, particular book will be generated, it will be a root node content. And suppose for all the books I am generating XML. So book one, book one, book one. So all those books information I want to put in a particular root node. So I can specify root. Inside that, whatever the root name I want to provide. So my comma elements means it will be creating a not attributes. Suppose if I remove that elements thing, then as I have shown you earlier, it will be put in all those attribute kind of things. But if I specify elements, it will be generated like node structure, it will be generated. And in that node structure, suppose if I want to put some attribute, then I can specify as @book ID, then it will be a what attribute, it will be treated as an attribute, that ID. So suppose I am select this book ID, publisher name, description. From this book info table, I can also specify where condition here. Suppose I want to filter it out with particular book ID. Suppose I have commented out for the time. Then for that book ID, suppose I want to outline all the general information for that particular book. So it will be a kind of subquery kind of thing. So for path XML also it will support the subquery thing, so that we can easily manipulate those data, we can easily manage those child parents kind of hierarchical thing. So I have written a subquery inside this outer one, so that it will be included in the outer content part, all the general information will be included. As you can see, this is the query I am retrieving from book genre information, that genre name and its description, and mark here I am joining book ID from main book table with the book genre table, as those are related. So it will automatically do a map there, and it will automatically extract those particular book ID, whatever we will be associating here, or whatever, I mean for a particular book it will be easily mapped among inner join it will do, and it will extract only those genres which are associated to particular book ID. So XML path means whatever name I'll be giving in here, it will generate node as per this genre name. Similarly goes for the book author informations, whatever name this is the book path, whatever node I want to give, whatever the authors I want to extract from that book, it will be generating here. Same goes for the book format also. So let's run and see what are the output results here. It has successfully run, and we have already generated the XML type. As you can see here, let me select so that it will. See, as in the code itself, I have specified the root will be content. Root will be content at the first root, so it will automatically generate a XML with content. And I have specified as book ID, so it is treated as, we have specified elements there, it will be creating elements node on node. But suppose we want to put attribute to that content node, so if I specify as attribute, it will be treated as a attribute for that content node, and it will simply create a attribute ID instead of node ID. So this is the attribute, and all those things we are not specify as we are directly specify publisher name, so it will be treated as a node name, and it is simply put under book ID 1, publisher is this one, book name is this one, and for the genre one I have specified the X path as genre there, so it has created a genre name for it, and inside that genre it is creating all the genre and book genre ID for that thing. So it has, as at this book is associated with two genres, it is automatically created two XML node. We can also manipulate, suppose I want these two genre into a root genre kind of thing. So also we can specify there. Currently it is directly put under content thing, but suppose I want this genre thing into a particular root node, and then simply, so we can also manage that thing by path mode by simply writing comma root, whatever root we want to give, like this thing, comma root name, comma type. So it will automatically encircle those two genre type into a single particular root node. Similarly goes for the book authors, it will generate book authors as there are two authors. Same goes for the book format. So if we specify, we haven't specified any where condition there, so it is creating all the content, all the books whatever available in our data. So if we want to suppose for book ID 2 we want only, then simply we can condition filter that condition with a where clause, and it will create our XML structure for book ID 2, right? So this is basically the for path mode. So this is the most efficient, I mean most you can handle easily from the other modes, and it is most easy to write those query. It is also supporting inner query, and we can also easily manage the schema of the XML. So any doubt till yet? Any questions, suggestions? Clear, right? Pretty much clear. Okay. So then let's go to the slide thing where we have read. We completed the path mode, and we seen through an examples how we will be using XML path for creating XML data and from our relational data tables. So let's imagine another situation here. Suppose suppose I have generated those XML data, right? I have generated this XML data. I want XML data, and I want to extract those XML data and put into my tables. Suppose I want to, from that XML kind of thing, suppose from my third party I am getting some XML data, and I want to extract each and every data from that XML types. So we can easily do that by using XQuery. This is called the XQuery. So this is opposite of XPath kind of thing. In the XPath, what we have done, we simply creating XML data from our relational data, and we are constructing this XML kind of thing. So this is opposite of that thing. Suppose we have this XML data, and suppose you want to retrieve those data. So how you can manage that thing? In XQuery, we can easily extract each and every bit node of an XML data. So, and it is also very, suppose whenever we are doing a large bulk instance of kind of thing, suppose we have a very much big data. Suppose we are doing some e-commerce book kind of thing, and from a third party tool we are exporting all those book information into our applications. So we want to keep those data into our database tables, relational database tables, right? So in that case, suppose if we are getting a large XML kind of thing, so if you use normal varchar and you use some functions and extract those things, it will be very slow. I mean, personally I have experienced those things. Suppose for inserting 3 lakhs data, it will take maximum 2 days. I mean, minimum 2 days for extracting all those. If your XML is very much unstructured and very much you are not sure about the nodes availability, you are not sure, we are not, suppose in XML data some invalid characters things are also there. So if you manage everything and handle every null, every special character, everything, then it will be very slow to import all those data into our database. But if we use XML type and XPath XQuery, it is very fast and it is very efficient. So for those records, whatever it will take 1 day or something, it will be taken in maximum 1 or 2 hours. Those data will be so this much of efficient that XPath XQuery is. And also this can be easily handle those exception kind of things. Suppose in the XPath you are getting some exception. Suppose during parsing retrieving you have got some exception, so we can easily handle all those error kind of thing by using try catch also. And also we can easily implement transaction, every SQL Server features in those XML, XQuery, XData thing. So we are already running out of time. So let's see how we can extract those data from. Suppose I have this XML as I have created from that XML path. I have a content book ID 1. I have publisher name as its immediate root, immediate child. Then book name. Then I have suppose two general informations. I have generated book for that particular book 1 ID with fiction and adventure. Then suppose that particular book ID 1 has 2 authors, Robin Sharma and Amish Tripathi. Then that book has supposed to format, PDF format and hard copy format. So I want to extract those data from those XMLs, and I just want to show that. So if we already extracted, then we can easily insert those data into our tables, right? So for doing that thing easily, I have created some variable container. So this is the, suppose I want to extract book ID, publisher name, book name, all those extracts. So I have already declare some of the variables. For to to show you guys, I have just declared those variables, so you can directly use that. But I have declared the variables so that we can store those and we can see whether it is correctly extracting those data from that XML or not. So this is my XML data, and as you can see, I have simply hard-coded that thing. So this is some string kind of thing, right? So I want to convert that string to XML type. These are varchar max, and we can easily convertible to varchar and varchar kind of thing. But XML data we cannot convert to text or and text kind of thing. But varchar we can easily interchangeable. So I have declared a variable XML data with type XML. So if I specify set, if I simply we can assign those XML data. I have specified XML data, and if I simply set XML data, this is a varchar max kind of thing. So internally it will take care of that thing and it will convert it to XML data. So we don't need to bother anything about that. So simply this XML data type is a XML type, and simply we can assign this varchar to XML type. So internally it has converted that thing to XML type. So how we can then extract those book information from that XML type is, first of all, we have to, there are some sort of syntaxes SQL Server is providing actually. So there is a keyword called value. Suppose this is a XML data, and let me select this. Suppose that is a XML data and there is a keyword value is there. So if you provide that value thing there, and if you pass the path, whatever path you want to extract, then it will, and also you can pass that thing. You can see that I am retrieving book ID. I am selecting @book ID. I am retrieving book ID from that content type, and I am internally passing it to varchar 50 and assigning to the @book ID, that variable. Same thing I am doing for the publisher name and the book name. I am from that content one, as you can see, book ID is an attribute. Suppose if that is an attribute one, content book ID is attribute. So we can simply dot value slash content slash @attribute. So it will automatically go to content, then that means it is identified, it is an attribute. So it will simply pick that book ID and whatever the value of that book ID, so it will extract one there. And this is mandatory. I mean, this is, you can say, syntax kind of thing. You have to must specify one there. So to get that data, I mean, one means this is exactly, this is that one we are retrieving. You have to specify one there. So if you want, as you have already seen that format, XML format, this is slash content @book ID. So it will extract that attribute ID and it will put into my book ID. Same goes for, as it is publisher name is directly node there. So content slash, if I set publisher name, it will immediately hit that publisher name node and it will extract that value. And internally I am specifying nvarchar 25, so internally it will convert it to nvarchar 255. Also for displaying purpose I am using nvarchar, but suppose in your you have integer type, you want to store some data kind of thing. Book ID should be integer kind of thing. So suppose we can also specify directly int there, but suppose at publisher name I have specified int, it will throw some exception kind of thing, right? So for that thing we can handle all those type of error through a try catch block there. As you can see, I have this is a try catch, and in the catch I have handled all those exception. Sorry, it is not, this is a catch, and I am getting what exactly the error message is, where the error line is getting, everything those. So whenever if there is any error in the XML parsing up kind of thing, so we can easily track what mapping fails and what exactly goes wrong. So same goes directly book information we retrieve. So these are the book information I am simply printing. We will see the output after explaining all. I'll come again. Then suppose I want to get the book author information. As you can see here, there are two author. There are two book author node for that particular book, as you can see. Right. So there are two authors. So if I want to show there are two authors. I will be showing author 1, author 2. So I want to do, for getting all those authors name, I must be doing some for each loop kind of thing. So that I'll be passing root node as book author and search for book author node. If I am saying rawly, search for book author node and check what are the number of book author nodes. Then simply I can get to know what are the numbers of books. And I will be doing a for each kind of thing. By suppose I get to know 2 authors, so I'll be looping 2 times with each book author node, and simply I'll be retrieving both author ID and both author name, whatever the name required. So for that thing, I have these are the normal, as you can see, author ID I want to display, so I have declared author ID. Author name I want to show, declare so author ID, and the counter is which book author it is counting. I mean, from if there are 2 node is there, then which book author now it is displaying. So there is, I have also declared another author node XML. So as I told earlier, so whenever there is a condition there when we should go for a XML model. Suppose from a large XML data with we need some of the part of the data. So suppose I have that book XML, suppose I need only that book author part. So through XML query, I simply need to query that XML path only, rather than instead of using whole XML data. So for that thing, I have declared another variable author node XMLs, and what I will do is from that book info, I will be simply extracting book author section, book author node I will be extracting, and I will be simply putting those author nodes there, so that I don't need to query those book information, general information, everything. For a if you use normal scalar functions, normally we need each and every check and everything it will do. But suppose if we use that author node XML and simply if you pass something like, see, content slash book author, it will be extracting all those book author nodes and it will be importing into my this node, author node. So I can easily manipulate part of a big data, insert, update, anything I can manipulate with this part. So for looking kind of thing, I am simply counting what are the book authors node, what are the number of book author nodes it is present. So total count I get, if you see, I am initializing counter to 1, and total count for that book author count is I am getting total numbers. I am specify there is a function there, count, and so it will count for book author node from that content, and it will put that value in total count, so that in that way I can easily get to know what are the number of book author nodes present in that XML. So with that number of thing, I will be looping for getting the book author information. Is that clear? Then in this code, I am simply doing a looping kind of thing to extract the book author information for each book author node. So as you can see here, as I told previously, book author I have simply one thing I have missed there. See, book author node, I am content slash book author, it will return all the book author node for me. But suppose as I am looping for the book author node, I want to know which position it is looping now, right? Suppose I have 3 book author nodes here, then first book author node, second book author node, third book author node. So how I can get those goes count to it? This is the syntax for that. There is a keyword query, so it will be querying only book author position 1, and this is the count. Suppose it will be looping through each book author node, right? So first book author count will be 1, and it will be setting for position 1. So in that XML node, first position, second position, third position, some must be position will be there, right? So it will be extracting according to the counter position 1, as we are doing a for each loop there, position 1. So that means it will be extracting this first book author node, this one. This is the position 1 in this XML, right? So it just select this book author node. Then I am selecting that section and importing into a XML node, and this XML node is a XML type I have specified above. So in that XML node, we will be simply querying whatever we have done to the book ID. In that XML node, we will be extracting directly from book author, directly book author ID I want to extract. So simply I can specify like this. Suppose I want book author ID, so simply I can extract book author ID. The same goes for then first node is complete, as I am doing a for each kind of loop, I will be increment the variable there to counter 1. Then again I will do, then again it will go for position number according to here. As you can see, this counter is now changed to 2, so it will hit that book author position 2, so it will go for this. This is the first position, this is the second position, so it will go for the position number 2. So simply it will, same way it will extract the data for me. So similarly we can use for genre and all those format information, we can easily extract all those data informations, and trust me, it is very fast. So let's execute how the data is being generated here. As you can see here, book information, I have extracted book ID to 1, publisher name, as you can see directly it is the Ajanta Publications. Another important thing is, it will also handle the empty kind of thing or null kind of thing. It will automatically, we don't need to check whether that node exists or not. It will automatically take care of that thing. If that path exactly particular that path didn't found, then it will automatically know that that node is not present, and it will automatically don't assign any value or don't assign any variable to the particular value. So everything is automatically take care. We don't have to take special attentions to any unknown things. Okay, so then as we know, we have two author node, we have for each looping. So as you can see, author node counter 1. So this is the first author, this is author ID 1 and the Robin Sharma. I can get the author name for the first author counter, I get the 1 and the name is Robin Sharma. Then same for the author node counter is 2. It has second author book author node. As you can, this is second book author node, and this book author node is author ID is 4 and author name is Amish Tripathi. This one you can easily trace, right? So it is very much simple enough, very much straightforward, and we can easily manipulate all those things. We can easily know everything. We can easily handle the error. If something goes wrong in the parsing, also we can easily roll back kind of thing. We can do rollback kind of thing, and this thing, and it will really very much fast and efficient. So any questions, comments? Understandable? Okay. So then we are almost done, and we have also shown all the demo. So guys, you can ask any questions if there is any difficulty in understanding all those. And also you can ping me in my Skype. I'll be uploading this seminar slides in that seminar page. And let me know if you have any questions. Guys from GTM, any doubt, any questions? I guess no. Then we are all done then. Thank you all. Thank you for your time and for this seminar. Thanks. Thank you all. Thanks guys. Thanks for your time.